Good morning, everyone. I am Saita Ahuja.
And I am Arbis Tehseen.
And I'm Atika Batul. So let's move on to the introduction to our bank management system. Our project is a bank management system developed in a few languages. It simulates real banking operations like account creation, deposits, withdrawals, fund transfers, and banking queries. This system is manual-driven, secure, and user-friendly, and it is designed to handle multiple users at the same time. Our team divided the work into different sections. I worked on the data storage help desk part, which formed the foundation of the system and help users navigate it easily. Now I will explain the data storage part of the system. In our bank management system, the data storage section is the base of the whole program. Our main goal here was to store and manage multiple users' information in a simple and organized way, without using files or databases. To achieve that, we used arrays because they let us store a group of similar data types together. For example, instead of making 100 separate variables for 100 users, we can just use one array like name and store all the character names in it. So arrays help us handle multiple accounts easily within one structure. We also use parallel arrays, meaning that every index in all arrays represents one specific customer. For example, the name having an array, the account having an array, the password and balance all belong to the same person. This makes it easier to access or update any customer records by using the same index number. We use different arrays for different types of data, like names in a character array, account numbers in an integer array, passwords in another character array, and balances in a float array. This approach keeps our data organized and type-safe, meaning each piece of information is stored in a right format. For transitions, we use 3D arrays, which might look complex, but it's actually very practical. Transitions 100, 10, 100 means for each of the 100 accounts, we can save 10 transition records and each record can be up to 100 characters long. Along with that, the task count keeps track of how many transitions each user has done. This way, we can easily show a mini statement for any user at any time. We also declared some supporting variables like total accounts, which help in keeping account of how many users are created, and account index, which tell us which user is currently active or logged in. These variables control the flow of data between user and actions and storage. So overall, our approach in the data storage part was to design a simple memory-based structure that can store all the information during the program execution and allow quick access whenever a function like deposit, withdraw, or transfer needs that data. Even though we didn't use file handling, our array-based approach made the system lightweight, fast, and easy to understand. Now Saita will continue.
So, the admin panel is the control center of the bank system, where the bank administrator can manage all accounts efficiently. Technically, we have used arrays to store all the account information. Specifically, we have arrays for names, account numbers, passwords, balances, and a three-dimensional array for the last 10 transactions of each account. To keep track of how many accounts exist, we have a counter variable. And for transactions, we used an other array to count the numbers of entries per account. We also used loops extensively to navigate through all accounts and transactions. For example, when we want to view all accounts or delete an account, a for loop checks each account until it finds the right one. We use conditional statements to check if the admin password is correct, if an account exists during deletion or password reset, and to ensure correct data handling. Switch case statements are used to create menus for both the main system and the admin panel. String functions like strcmp and strcpy are used to securely compare and update passwords or names. So, so now let me explain the features of the admin panel. Add a new account. When the admin selects this option, the system asks for the user's name, account number, password, and initial balance. Using array indexing, all this information is stored in the next available position in the arrays. The total account counter is then incremented. This ensures that the new accounts are added sequentially and safely. So the next option is delete an account. When the admin enters an account number to delete, the program uses a loop to search for the account in the arrays. If found, the account is removed by shifting all subsequent arrays and elements up, which maintains data consistency, and the total account cell counter is reduced by 1. The third one is view all accounts. This feature uses a loop to go through all the accounts and print the name, account number, and current balance for each one. And the last one is reset password. Here, the admin enters the account number and the program searches the arrays to find it. Once found, the admin enters a new password, which is updated in the passwords array using strcpy. This ensures the password is changed only for the selected account and the system remains secure. So every part of the admin panel is designed using arrays, loops, counters, switch cases, conditional statements, and string handling, which together make the program dynamic and reliable. Whenever accounts are added, deleted, or updated, the system automatically keeps all data consistent and accessible. So now we'll run the program for the admin panel. So for admin login, we'll go to the option 1. So admin has a hard-coded password to maintain security. So if admin writes his password, he'll get access to all the features of the admin panel, which I already have discussed, that add new account, delete account. So let's go through all of these one by one. Let's add a new account first. So for that, you'll have to enter your name and then your account number, and you have to set a password for the safety, and you have to write your initial amount which you have to deposit. So account has been created. So let's make 2 more accounts to look at more functions properly. So I'll make another account named Sarah, and I'll make one more account, which is Zara. So now I have successfully made 3 accounts. So now I'll show you how to delete an account. So for deleting the account, we'll go to the option 2, and then I have to write the account number which I have to delete. For example, I have to delete the second account. I'll write the account number and my account has been deleted. Now let's view all accounts. When we'll view the accounts, we have only got 2 accounts, which is account number 1 and account number 3, because account number 2 has been deleted. We can also reset the password If I have to reset the password, I'll write the account number. So for example, I have to reset the password for account number 1, and I'll just write a new password which I want, and my password has been reset. So these are the options for the admin panel. Now we can go back to the main menu to use our bank management system. So now Urbish will continue.
Hello everyone. Now I'll explain the ATM services module of our bank management system. This module is designed for customers, allowing them to perform key banking operations such as withdrawing, depositing, transferring money, checking balance, and viewing their mini statement. It uses the same arrays that were declared globally to store all account information, including names, account numbers, passwords, balances, and transaction history. The total accounts variable keeps track of how many users are currently registered in the system. So the number one point is login system. When a user selects ATM services, the system first asks for the account number and password. A loop. For loop runs through all stored accounts and uses strcmp, which is strings library, to compare the entered account number and password with the saved ones. If both match, then login is successful. Otherwise, an if condition prints invalid login. In the backend, once login is verified, the system stores the user's index position, which is then used to directly access or modify their data in arrays. If credentials are incorrect, the loop completes without finding a match and no account operations are allowed. The number two choice is withdraw money. The first option after login is withdraw money. When the user enters the amount to withdraw, and if condition checks whether the balance is greater than or equal to that amount. If yes, the program subtracts from it the program subtract it from the balance array of that particular user. The withdrawal detail is then saved in the 2D transaction array with the tag withdraw minus amount. In the backend, this is done using array indexing. If the balance is not enough, the else block triggers and shows insufficient balance. This prevents the program from going into negative values. The number third option is deposit money. The next feature is deposit money. Here, the system takes the deposit amount and adds it to the balance array for that user. It also appends a transaction record in the user's transaction log using printf and strcpy. In the backend, this is done using balance array indexing plus equals to deposit and strcpy. Loops and counters are used to ensure the new transaction is stored in the right slot and old ones shift up if the limit of 10 transactions is reached. The number fourth feature is checking balance. The check balance option displays the current account balance by simply reading from the balance array using the user's index number. It doesn't use any condition or loop, just a direct array access to fetch the balance value. This feature demonstrates how stored data in memory can be retrieved instantly without recalculation. If no account is logged in, this part remains inaccessible, preventing any unwanted access. The number fifth feature is transfer money. The transfer money feature allows one user to send money to another account. The system first asks for the receiver's account number and transfer amount. Then a loop searches through all accounts using strcmp to find the receiver. If found and the sender has sufficient balance, the amount is deducted from the sender's place and added to the receiver's balance. Both transaction logs are updated separately, senders as transfer out and receivers as transfer in. In the backend, this part combines loops, if conditions, and string operations. If no matching account is found, or if funds are insufficient, the system jumps to the else condition and displays transfer failed.